All right, so today we're going to take what we learned yesterday, vertical translations, horizontal translations, reflections, and stretches and compressions. We're going to take that and we're going to apply it to other graphs. So the square root graph and the absolute value graph and cubes and cube roots. And it's all the same concept. So let's start with a little bit of review. So we're going to start with our parent function. So this right here is our parent function. Y equals x squared. Let's get that graphed over here. So when x is 0, we have 0, 0. When x is 1, 1 squared is 1, so 1, 1. When x is negative 1 squared is 1. When x is 2, 2 squared is 4, so 2, 1, 2, 3, 4. And when x is negative 2 squared is also 4. And I'm going to pick a thinner line to draw that. So let's try that. And please don't judge me on my graphs today because they're going to be a little rough. So that's your parent function. And in your homework tonight, you're actually going to start with the parent function every time. So I do want the parent function on the graph. And then preferably in a different color, maybe like pen and pencil, or if you have colored pencils, that'd be awesome. Then you'll graph your new transformation. But first, I also in the homework today want you to tell me what happened. So what does that plus 7 do? Well, it's on the end, so it's going to move it up 7. And then graph it. So all you have to do is take that parent function and move it up 7. So from here, 1, 2, 3, 4, 5, 6, 7. And then here, 1, 2, 3, 4, 5, 6, 7. Same concept over here. Here. And there's your new graph. So I do want to see 5 points plotted. Okay. I want to see the parent function and I want to see the new function, preferably in a different color. And then also please tell me what's happening. Explain the transformation. So this is what I'm expecting in your homework tonight. All right, so that part's review. You already did x squared functions yesterday. But now let's apply that to some new graphs. Maybe the square root of x. So we haven't really done this one yet, so we're going to do it. I'm going to keep my parent functions in blue. So this right here is your parent function. So let's make a little t-chart here. All right, let's plug in 0. Square root of 0 is 0. Square root of 1 is 1. I'm probably not going to do square root of 2 because that's going to be a decimal. So I'm going to choose 4. Square root of 4 is 2. Now also, usually we do some positives and some negatives. But be careful here because your square root function, your domain is limited. Your domain is limited. You cannot have a negative x value because it's imaginary. So we can't do the square root of negative 1 or the square root of negative 4. So we're only going to have those positive x values. And again, that's going to limit the domain of our graph. Sorry, I don't know why I didn't scoot it up already. All right, so let's go ahead and graph that parent function. So 0, 0, 1, 1, 2, 1, 2, 3, 4. Just kidding. I totally read that backwards. 1, 2, 3, 4, 1, 2. There we go. 4, 2. And you'll notice it's like half a parabola, right? It's half that parabola, but again, only going the positive direction. We don't have any negative here. All right, so that's our parent function. Now that we have our parent function, let me change my color, we can explain what's happening here. So just like yesterday, if it's grouped with the x, remember to kind of think opposite. So when I see +1, I'm actually moving to the left one. So you're going to tell me it moves left 1. And then over here off to the side, we're going to move down 4. So that's what's happening. We're going to move left 1 and down 1, 2, 3, 4. And then up 1 over 1, up 1 over 1, 2, 3, up 1 over 1, 2, 3, and we have that graph. So we have our parent function and our new function, and I explained what happened. So again, this is what I'm expecting in your homework tonight. I want you to explain and graph both. All right, moving on. Absolute value. So let me get my parent function, my blue. So again, we haven't really talked about this graph, but let's plug in some values and see. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. All right, let's try some negatives. Absolute value of -1 is +1. All right, remember absolute value means take the positive. Means distance from 0, but again, positive. Absolute value of -2 is 2. I feel like we're good to graph. So we got 0, 0, 1, 1, -1, 1, 2, 2. And the way I always remember it is its absolute value, and it's a V. So value V. And that's how I remember what that graph looks like. Now let's change our color and let's explain what's happening. So that negative, we know it's going to reflect. So it's going to flip over. The 2, notice it's grouped with the x. So that's your left and right. Plus, again, is going to move to the left. 2. And then on the end, we're going to move up 3. So again, I want this in your homework tonight. And then do it. So the reflect we'll deal with in a second. Let's move our vertex. So we're going to move it left 2, 1, 2, up 1, 2, 3. So there's my new vertex. And now notice you go over 1, up 1, over 1, up 1, over 1, up 1. So instead of going over 1, up 1, we're going to go over 1, down 1. It's going to open down. Over 1, down 1. Over 1, down 1. And there's your graph. And guys, if you're ever in a pickle, okay, if you're ever in a pickle and you just don't remember, you can always go back old school and make a T-chart. Now, the whole point of this is to avoid T-charts, so we're going to try and base them off our parent functions, but if you're ever in a pickle on SAT, ACT, anything like that, you can always go back and plug in values to remember what the graph looks like. All right, moving on. Ooh, cubes. Cubes. These are the fun ones. So let me get my parent function blue. There's our parent function. So let's, again, we're going to start off with that parent function. We should get familiar with what the graphs look like. 0 cubed is 0, 1 cubed is 1, 2 cubed, 2 times 2 times 2 is 8. Yikes, we're going to get some big numbers here. And then, what do we got? -1 is -1. Right, -1 times -1 times -1 is actually -1. -2 is -8. And let's graph. So we got 0, 0, 1, 1, and then we have -1, -1, and then we have 2, 1, 2, 3, 4, 5, 6, 7, 8, and we have 2, 1, 2, 3, 4, 5, 6, 7, 8. You might say, what on earth does this graph look like? So it's actually a little S-curve. So this kind of curves down. So you get like kind of like a little S curve going on here. And then let's go to our next one. So here, what's going to happen? We're going to move it down 1. So we're going to move everything down 1. Down 1. Down 1. Down 1. Down 1. And there's our new graph. Alright, so we just shifted it down 1. So we have that S curve for our x cubed. Cube root of x. Again, think of numbers when you're graphing this parent function, think of numbers you know the cube root of. So here, we know the cube root of 0 is 0. Cube root of 1 is 1. But we don't know 2, 3, 4. We know 8. Cube root of 8 is 2. 2 times 2 times 2. And then you got the negatives. Negative 1, negative 8. So you got negative 1, negative 2. Alright, so let's graph. 0, 0, 1, 1, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. So notice it's going to be an S curve, but it's going to be going the other way. So the negative 1, 2, 4, 5, 6, 7, 8, 1, 2. So instead of hugging the y-axis, now it's kind of hugging the x-axis. Here we go. So it's just a little S curve going the other way. And then let's do our transformation. So since it's grouped in with the x, we're going to be moving to the left 2. So take all your points and left 1, 2, left 1, 2, left 1, 2, left 1, 2, and left 1, 2, and we're going to make our new S, which I am terrible on this pen. I'm so sorry. I'm sorry, that is messed up, but you get the gist. It should look like this. But you can, like I said, you get the gist. Don't judge my drawings. But yeah, so you should be moving it to the left to that S curve. All right, and then our little bonus question, just to kind of get all of it in. Stretches and compressions. What I want you to do with stretches and compressions is actually change your parent function. So instead of using y equals x squared here, I'm going to use y equals 2x squared, and I'm going to graph that as my parent function. That way you don't have to deal with the stretch or compression later. So 0 would be still 0. 1 would be 2. And 2 times 2 times 2 would be 8. And then negatives. Negative 1 would be 2. Negative 2 would be 8 still. So go ahead and graph that as your parent function. And I know that's a little weird. So whenever you have a stretch or compression, just go ahead and graph a new parent function. It makes your life a lot easier. And then 2, 1, 2, 3, 4, 5, 6, 7, 8. And here, so notice here I got tall and skinny. That was that stretch because the 2 value out front. That 2 was bigger than 1, so it was a stretch to get tall and skinny. And then tell me what's going to happen. So it's a reflection. It's moving left 3 and down 1. So we're going to get a new color. And you don't even have to worry about that 2 now because you already dealt with it. So now we're going to take this, we're going to reflect, and we're going to move left 1, 2, 3, down 1. And see how you go over 1, up 2? We're going to go over 1, down 2. Over 1, down 2. And then over 1, up 1, 2, 3, 4, 5, 6. So here, over 1, 1, 2, 3, 4, 5, 6. And copy paste.